Okay, so we are talking about epsilon NFA to NFA. So, we take this so we will discuss two examples. So, just to recap, we have given a epsilon NFA. Now, we want to construct a NFA which will accept the same string delta prime q 0 and f prime. So, delta prime we are defining as delta prime we are defining as q comma a. So, here there is no epsilon move for this n. So, this is nothing but delta hat, this delta hat of q comma a. So, we are just clubbing the all the epsilon move before a after a in this deltas. So, that is why we use the delta hat. And what is f? F is f prime. F prime is f union q 0 if from q 0 we can go to any state of the f just by epsilon move. If the epsilon closure of q 0 and f is not empty, otherwise it is just a f otherwise. Okay. So, this we have seen. Now, we will take some example on such construction. Okay. So, epsilon NFA is having the epsilon move and NFA is not having any epsilon move. So, that is the difference. Okay, let us go back to that same example q 0, q 1 and q 2. So, this is our 0, 1, 2 and this is epsilon move, this is the starting state and this is the final state. So, this is our E and we know that L of E is 0 star, 1 star, 2 star. So, any string of any number of zeros followed by any string of any number of ones followed by any string of any number of 2. So, that is the language by this epsilon NFA. Now, we want to construct the equivalent NFA. So, to construct, so this is just we can write the rules. So, this is 0, 1, 2, epsilon is here and these are the states q 0, q 1, q 2 and this is our delta. Now, from q 0 with 0 we have this, from q 1 we have, from q 0 there is no move for 1, there is no move for this, but there is a move for epsilon null string. Similarly, this is empty, this is q 1, this is empty and this is q 2 and this is empty empty and from q 2 with 2 we can go to q 2 and with epsilon there is no move. So, this is the transition rule for this epsilon NFA. Now, we will construct the corresponding NFA. So, for corresponding NFA the state will be same and this sigma will be same alphabet set. Here we are not having epsilon move. Delta prime, this is prime and we have q 0 and f will be changing because here with the epsilon move we can go to q 0 to q 2. So, that means q 0 has to be added in the this final state. Okay. So, how to write this? So, basically delta hat we have to define. So, here we have move 1 2. Now, here state are same q 0. So, we will write a space 0 1 2. Okay, Q0, Q1, Q2. Now, suppose we are at Q0. Now, with 0, so delta prime of Q0 0 you want to find. So, this is nothing but delta hat of Q0 0, delta hat, I mean this delta hat for this delta, for the epsilon NFA delta. So, for delta hat of Q0 0, what we do? We treat this as a epsilon and this also epsilon. So, this is nothing but we can just from Q0 we will see where we can go with the epsilon move. So, we can go to Q1, we can go to Q2, and then from each of that whether we can take a 0 move. So, from Q0 we can go to again Q0 and then we can take a epsilon move. So, this will be basically the whole set Q0, Q1, Q2, because each of these state is reachable with the delta hat of Q0 0, because that includes, because we have to include the epsilon closure inside this, because we do not have epsilon move in the NFA, normal NFA. So, this is Q0, Q1, Q2. Okay. So, now delta hat of Q0 1. So, Q0 1. So, this we want to find out. So, this is nothing but a delta prime, delta hat of Q0 1. So, from Q0 again we can go to with epsilon move we can go to Q0, we can go to Q1 and Q0, from Q1 and Q0 with the 1 we can remain at Q1. So, again with epsilon move we can go to Q2. So, it is basically Q1 and Q2. Okay. So, this is the, and this one is with Q delta prime of Q0 2, where we can go with Q0 2, we can go to from with epsilon we can go to Q1, but after that there is no move with 2. So, this will be empty, this will be yeah, but with epsilon move again we can go to Q2. So, this will be only Q2. So, this will be Q2. Now, from Q1 to Q1 with 0. So, delta prime of Q1 with 0, it will be basically. So, from Q1 if we have epsilon move we can go to Q2, but from there we have no move for 0 and then. So, this will be basically empty. So, this is empty. Again similarly we can find this is Q1 Q2 and this is Q2, and from Q2 this is empty, and this is Q2. Okay. So, this is the corresponding NFA. So, if you draw this, this will be like this. So, we start with Q0, then we can go to Q1 and Q2. Here the final state is both Q0 and Q2. Okay. With 0 we can go from here, also here, also here. With 1 we can go to Q1. So, this is 0 or 1, we can go to Q1 or Q2, 0 1. With 2 we can go to Q2, 0 1 2. Okay. And from Q1 with 0 there is no move, with 1 we can be at this or we can go to Q2, and with 2 we can go to Q2, and from Q2 we have no move for 0, no move for 1, only we have move with 2. So, this is the corresponding NFA. This is our corresponding, and which is accepting the same language, because if you take 0 star, 1 star, 2 star. So, any number of zeros. So, any number of zeros it will reach to the final state. Even only 0, if we have only 0 input, it is already final state. So, it is remain there, because here we have not having epsilon move. Epsilon closure we have included in the delta hat of that this. So, this is accepting the same language. Even for 0 followed by 1, if we have a 1, we can just hop here or we can go there like this. So, this is the equivalence NFA. So, from epsilon NFA we can construct a equivalence NFA. So, we will take another example, then we will see how we can go back to the DFA. So, from epsilon NFA we can construct a NFA, and then from NFA again we can construct a corresponding DFA. So, that we will see now. Okay, so, let us construct this. We take another example to convert the this epsilon NFA to NFA. So, this example we have seen. So, this is basically the Q0, then we have Q1, we have epsilon plus dot, sorry, this is not dot, this is minus, and if we have a digit, we will be hopping there 0 to 9. We have seen this example, and we have a dot, we will go to Q2, and from Q2 we will go to Q3. If we have a digit input 0 to 9, and from Q3 we hop here if we have a digit input, and finally we will go for Q4 with a epsilon move from here, and from this is Q5, this is Q5, and we have Q4 over here. So, Q4 from Q1, if we have a digit 0, 1 to 9, we will go there, and if we have a dot over here, we will go there. Okay. So, our sigma is plus dot, also epsilon is there 0, 1, 2 up to 9 along with the epsilon move. So, this is our E, epsilon NFA, and we have seen some of the string accepting this epsilon NFA like 5.6. We have constructed those even yeah. So, now we want to see how we can construct a NFA from this epsilon NFA. So, for NFA what we need to do? So, suppose this is the NFA Q F prime. F prime is only different is if we can form Q0, if with the epsilon move we can reach to the final state. So, this is our final state. So, no, we cannot reach to the final state only with the F. So, F prime is same as F over here. Okay. Now, we can construct this delta prime of Q comma A is nothing but delta hat of Q comma A to take care of the epsilon move before A after A. So, that way we will just get the corresponding NFA. So, let me just okay. So, let me just draw this picture over here Q0 in a smaller way q1. So, plus minus epsilon, and then we have 0 1 up to n up to 9. We have a dot q2, and then 0 1 9 we have q3, and then from here we can go to q4 with a dot no, with 0 1 9, and with dot we are going to q5, and with q3 we will hop here with the same input, and then finally from here we are reaching to q5, which is the final state. Okay. So, now we have to construct the corresponding NFA, basically the delta. So, delta prime we will just define now. So, it has all the states q0, q1, q2, q3, q4, q5, and we have all the alphabet plus dot, plus minus dot, and all the digits. We can say 0 to 9. Okay, so, this is the starting state. Now, from q0 with plus, where we can go? From q0 with plus. So, basically delta of q0 plus, this is nothing but delta hat of q0 plus, we need to find out there. Okay, so, delta hat of q0 plus. So, for plus we can have a epsilon move before that. So, we can go to q1. From q1 we cannot go anywhere with the plus, or plus we can go to q1. So, it is remain at q1. Okay. So, then with the minus, again the same thing q1, with the dot where we can go? We can take epsilon move here, we can go to q1, and from q1 with dot we can go to q2, and there is no epsilon move, we can remain at there. So, this is q2, and with the digit where we can go? With the digit we can go to we can take epsilon move, we go to q1, and with the digit we can go to with the digit we can go to q1 and q4. So, this is q1 and q4. Now, this will be empty, because with q1 with plus there is no move, even no epsilon move also. So, in fact, these are all empty, this is also empty, these are all empty, you can easily verify, and with this delta hat of q0 dot. So, this will be q0 dot. With dot where we can go? So, with dot we can go to from q1, q1, from q1 with dot there is no epsilon move. So, we can go to q2 at most. So, this is q2, and from q1 with number where we can go? We can go to either q1 or q4, q1 or q4. Okay. So, this way if we complete it, so this will be empty, this will be again q3 and q5. We can easily verify this, because with q2 with the digit where we can go? We can go to q3, and from q3 we can go to q5 with the epsilon move. So, q3 and q5. So, this is q3 5, and this is for q3 we can go to q3 and q5, and this will be q3 q5, and this is empty. You can easily verify this. this is empty. So, this is the corresponding NFA. So, if we draw this, let me just check this. Yeah, we can draw this. Yeah, we can draw this NFA. If we draw this, it will be looks like this. So, Q 0 and we have Q 1, Q 2, we can have Q 4 over here and then Q 3 and we have Q 5. So, here at the connection, this is the starting state, this I am drawing the NFA, this NFA. Okay, from Q 0 we can go with dot, we can go to Q 2 and with plus with Q with the plus and minus we can go to Q 1, with the plus and minus we can go to Q 1 and with this symbol we can go to 0 to 9, we can go to either Q 1 or Q 4, any of the digit. And from Q 1 with the dot we can go to Q 2 and from Q 1 with this digit we can go to Q 1. So, this is a self loop with 0 to 9 any symbol any this and we can go to Q 4 0 to 9 I mean any digit from 0 to 9 and from Q 4 sorry Q 3. So, this is Q 2 Q 1 Q 2 from Q 2 where we can go to Q 3 and Q 5. So, Q 3 we can go with the 0 to 9 and from Q 2 we can go to Q 5 also. From Q 2 Q 2 we can go to Q 5 with the 0 to 9. Okay. Now, from Q 3 where we can go, we can remain at Q 3 with 0 9 or we can go to Q 5 from Q 3 we can go to Q 5 with 0 to 9. Okay, this is Q 5. Now, from Q 4 from Q 4 where we can go, we have only one move for dot. So, with dot we can go to Q 3, from Q 4 with dot we can go to Q 3 or with the or we can go to Q 5 with dot and Q 5 is the final state. Okay. So, this is the corresponding this is our epsilon NFA and this is the corresponding NFA. Now, the question is how we can. So, you can easily check these two are equivalent, the same language is accepting for both the cases. Only thing we are just absorbing the epsilon closure before the symbol and after the symbol, nothing else, and this is the final state for this. Now, the question is how we can convert this to a DFA. So, from epsilon NFA to DFA. So, we first convert epsilon NFA to NFA, then from NFA to DFA. So, that we will do by this. So, just we will take the corresponding DFA. So, this is the this is epsilon NFA, this is our NFA. Now, what will be the corresponding DFA? So, for DFA we know we will do it from here, not directly. There is a method to do that directly, we will discuss in the next class, but we will just convert epsilon NFA to NFA and from the NFA we will convert to the DFA by subset construction. We have seen this before. Okay. So, for subset construction method what we will do? We will consider all the subsets of this state as a possible state of the DFA, which is only we will not consider all the subsets, we will consider those subsets which is reachable from Q 0. So, if we do that, we will end up with this delta. I leave this as an exercise, I will just write the. So, this is Q 0 and we have another states Q 1 will come, these are the only subset which are reachable from Q 0, Q 1, Q 4 and Q 3, Q 5 and we have Q 1, Q 3, Q 5, and these two are the final state, because it contain the this. Okay. So, if we just quickly write this in the lecture note, it will be given. This is Q 2 and this is Q 1, Q 4, Q 1, Q 4 is there, and this is empty, empty, empty. Sorry, this is not empty, this is Q 2 and Q 1, Q 4 and this is empty, this is empty, this is empty, Q 3, Q 5, empty, empty, Q 1, Q 3, Q 5, this is Q 1, Q 4 and this one will be empty, 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 Q 3, Q 5, which is the final state, and the last one is, and this one also Q 3, Q 5. Okay. So, we can easily verify this. So, from this NFA we have constructed this DFA by the subset construction rule. So, we are just taking all the subset which are reachable from, we are not considering the date state, date subset, we are considering all the subset which are reachable from Q 0. So, these are the possible subset and these are the this is the delta. So, this is the corresponding DFA for this, and we can easily check this is accepting the same language. So, from a given epsilon NFA we can go for a NFA, from NFA we can go for a DFA which is accepting the same language. Thank you.